All right, so today we're going to look at doing negative scale factors with the center at the origin. So, as always, we want to mark the center of enlargement. So our center of enlargement, as we said, is the origin right there at 0, 0. Now, just because it's a negative scale factor doesn't mean we're going to change anything. It just, well, it means we're going to change a little, I should say. But it doesn't mean we're going to change anything about our process. It's just where our points are going to appear is just in a different spot. So uh, we still want to indicate how far away we are. So here we're 1 away. So that 1 times by our scale factor, we're going to take it as 2. Okay, we're going to leave the negative alone, and we're going to just use a conceptual part of it. So that means where our shape is going to end up is 2 away from the center. So if we go down though, now we're going to go up. So that negative, so a negative, sorry, let me rewrite that. A negative changes your direction. It's really slow, my pen, I apologize. So negative changes the direction. Okay, so we go 2 up. Same thing with the other points. We can look down, and well, we're 1.5 spaces down. So 1.5 times by our 2 is going to be 3 up, and so on. But just like we did with the other ones, drawing the lines can actually be very beneficial when you're dealing with negative scale factors because they appear in a completely brand new place. Especially if it's your first time seeing these, draw in these lines right now. Okay, so we're going to choose point by point, and I'm going to go around our shape clockwise. So the next point we're going to choose is this point. So we've gone that 1 down, but now we're going 2 over. Well, we know that 2 times by 2 equals 4. So now we went 1 down and 2 over. So that's going to be 2 up and 4 left for that next point. So from our center, we're going to go 2 up, and we're going to go 1, 2, 3, 4 over. And if you look at that, it lines right on where our dotted line is. So we could keep doing it with our point, but let's try and start seeing where our little tricks apply. So here we're going 1 down. So up here it means we're going to go 2 up, right? Reverse direction and times still by our scale factor. So 2 up, so we can make our next point here. Similarly, we're supposed to be 1 to the left, but we're going to go 1 to the right. And it matches up right there. Then we have a half point down, or up, sorry, is going to become a 1 point down. And then we are going to continue going over. Sorry, I mislabeled that last point 2 points ago. It should be there and there. And then lastly, we can connect with our final space. So that's also why drawing the lines can sometimes be confusing. As you notice what I did right there is that you might put it on the wrong dotted line. So always go back and double check that your shape does look like your original, kind of like I did there. That's sometimes what the long pauses are because it's lots of looking back and forth to make sure that it looks the same. So we're going to do another example, and I'm going to show you a little bit different of a method that's a little bit more mathematical of what happens with this negative. Sorry, not the practice problems. So why are we treating this negative this way? Okay. So here, let's instead of kind of drawing lines and doing all that. This time I'm going to pick out the coordinate points. So here, this is point, we'll call this, we'll just label these with A, B, and C, the points. And over here, I'm just going to say A is equal to, well, that's 0.5 and 0.5, right? We have B, and this is going to be 1, comma 1, and C is at 2.5 and 0.5. Okay, so I should point out something that this method right now, we're using it for the origin as our center, okay? Because this is a very special case because our coordinate system is defined as our based on our origin. This method does work, but you have to know a little bit about vector analysis first. So I can do a little bit of a show with that as requested, but I will just show you this based for the origin method. So you might be able to pick it up on the next video. So here, all we're going to do is take this minus 3 here, and we're going to multiply it individually by each of the numbers one at a time. So I'm going to do these in red, but I'm also going to put them with a little, I call it a prime when I put a little tick. Some people call it a flash, but you could just say a tick, doesn't matter. So here we're going to do 0.5 times by negative 3 and 0.5 times by negative 3. So our coordinate for our shape afterwards will be negative 1.5 and negative 1.5. Then we can do the same thing with b prime, and we can do 1 times negative 3, and 1 times negative 3, which will give us negative 3, negative 3. And lastly, 2.5 times negative 3, well, and 0.5 times negative 3. And that'll give us, well, 2.5 times 2 is 5, and then plus 2.5 will give us 7.5. Don't forget to put the negative. And 0.5 times 3 is, again, 1.5 in the negative. So let's plot all these new points that we have. So we have negative 1.5, negative 1.5. So negative 1.5, negative 1.5. So this is our A prime. B prime then is at negative 3, negative 3. So we'll call this B prime. And lastly, our C prime is negative 7.5, negative 1.5. So negative 7.5, we can't even fit on here, and negative 1.5 would be down here, right? So it'd be somewhere like here. If you're using a bigger piece of graph paper, this will work out a lot better for you. However, I wanted to show at the same time, more so with this example, an easier way to do enlargements. So this method of doing in negative scale factors that I've just shown you, you can actually go back and apply it to all other types of enlargements. Okay, so to show you that, I'm actually going to go back to our previous example right here as a kind of proof of concept. Okay, so I think it's very important to go back and try different methods because everybody will like a different method, and also you can use some methods to check other methods. That's a great beauty of mathematics. So here, let's just do this with a couple points. So I'm going to pick a few random points. I'll just call that A. I'm going to call that B. And we know the ones on the lines work, so we'll call that C. So with A, that is already what point we use, but we're going to see if it lines back where we want to on on our original shape. So this is -4, or actually, yeah, actually, sorry, change my thought. Let's do our original because we already have our scale factor. Let's not confuse more than we have to. So A is 2 and -1, and we have B is 2 and -2, and lastly we have C, and C is 1, -2. So now what we're going to do is we're going to, and I apologize for kind of the messiness of the page, I'm going to try and do this on the left-hand side here. So we're going to take each of these and multiply by -2. So A prime, as I'll call it, should be -4 and 2 when we multiply it. Then we have B prime, and 2 times -2 is -4. -2 times -2 is +4. And lastly, C prime will give us -2 and 4. So let's go back and let's just plot these on our shape that we drew. So -4 and 2, I'm going to do these in blue. So -4 and 2 is there. Well, that is A prime. We've just figured out A, that's exactly where we marked A, where it should have moved before. Then we look at B. Well, B prime is -4, 4. That's this spot. Well, that's exactly where we thought it would be, so we're happy there too. And lastly, C and C prime, -4, or sorry, 1 and -2, or sorry, -2 and 4. -2 and 4, we have it there. That's this. I was getting myself confused. And it's exactly where we'd expected. So proof of concept that this does indeed work. So at this point, you may use either method. I would go with whatever you're most comfortable with. I personally like this second method because it's a lot more mathematical, less drawing, and less based on kind of having a ruler and needing all that materials. So at this point, you have 2 practice problems to give it a go. So pause the video now, and as usual, whenever you need, you may press play. Okay, so we're doing this problem here. I'm going to choose the second method to start going through that with you because you've had enough practice on doing it the one way that we should get some practice. Plus, it's an easier method, like I said, for these. So let's pick out some coordinate points. And so A, B, C, D. So let's just make a list of our coordinates down here on the left. So A, B, C, D. Get ourselves some brackets. All set up. So A is the point 1, 2. B is the point 2.5. Sorry about that. 2.5 and 2. C is the point 2.51. And D is the point 1, 1. So our scale factor is 2. That means we're going to take each of these points and we're going to multiply by -2. So I'm just going to write what they are beside in red, and then plot in red. So -2 and -4. Here we have -5 and -4. Here we have -5 and -2. And lastly, -2 and -2. So let's plot the points, -2 and -4. Then we have -5 and -4. Then we have -5 and -2. And then we have -2, -2. And finally, we may connect our lines. So there we are. Like I said, it is very important to still know that other method because when we go to describing transformations and you're going to have to draw lines and be able to go the reverse process, this method is a lot harder to actually do that way. So here, let's do the exact same thing. I'm going to indicate 3 of my points, A, B, and C. So A, B, and C. A is the point, -2 and 1. B is the point, -2 and -2. And C is the point, 0 and -2. Once again, I'll do these ones in red to show what they transform to. So -2 times -2 is 4. 1 times -2 is -2. Then we have -2 times -2, which is 4. Same thing for its partner beside it. And lastly, anything times nothing is nothing, and -2 times -2 is 4. So let's plot these points quickly. 4, -2 is here. Then we have 4, 4 is up here. And then we have 0 and 4. So we have to, sorry, like that in the wrong spot. So we have lastly 0 and 4. Last thing we're going to do is draw our lines to connect because we're not quite finished yet. And now we are completely done.